Meet Ansible, the open-source automation engine from Red Hat. It handles configuration management, application deployment, and orchestration across your entire IT estate. Think of a control room where one operator commands an army of servers. That is Ansible. One brain, hundreds of machines, all moving in sync. Ansible is written in Python and speaks YAML, a human-readable language that reads almost like English, so your automation files double as documentation. Ansible is idempotent. Running the same playbook twice produces the same result, so it is always safe to reapply. There are no agents to install, no daemons to babysit, and the learning curve is famously gentle. The architecture is agentless. Managed nodes only need Python, and an SSH port open. The control node runs Ansible, opens a session, does the work, and walks away clean. It uses a push-based model. The control node reaches out over SSH, drops a small Python module onto the target, runs it, gathers the results, and removes the module when finished. Targets are defined in an inventory file, a simple ini or YAML list of hosts, grouped by purpose. A web servers group can hold entries like web1 Ansible_host equals 10.0.0.1, and Ansible routes jobs accordingly. 4 quick tasks, ad hoc commands get the job done in one line. Ansible all, mping. For anything repeatable, you write a playbook, a YAML file that orchestrates multi-step work across your fleet, version-controlled and shareable. Before any Ansible run, confirm that passwordless SSH to localhost actually works. Without it, every playbook and ad hoc command will silently fail. A quick batch mode test tells you in one line whether the control node can reach itself. Next, confirm the Ansible core is installed and grab the version banner. This matters because module behavior and inventory syntax differ across major releases. Piping through head keeps the output tidy. Ansible's inventory is just a plain text file mapping hostnames to groups. No daemon, no database. Here the inventory at /tmp/inv declares a single group called local with one member, localhost. The ping module is the canonical smoke test for an Ansible inventory. If it returns pong with a JSON blob showing changed equals false, the control node can reach the host, the Python interpreter is reachable, and basic module execution works. Once connectivity is confirmed, you can run any module ad hoc, including shell, which executes an arbitrary command on the remote host. Asking for uname is a clean way to prove a real command ran and return the kernel release. The change status is important. Ansible treats every shell execution as a state change unless told otherwise, because it cannot know whether the command was idempotent. That is why shell is powerful for one-off diagnostics, but rarely used in production playbooks. Finally, verify the kernel release on the host directly to confirm it matches what Ansible reported. A simple cross-check that the ad hoc shell module truly reflected reality on localhost.